I, Dr. Piyush Chaudhary, heartily welcomes our
This
first
meeting is being recorded.
heartily welcomes our first speaker of the day, Dr. Pavani Kadyal ma'am, and Dr. DPS Badwal sir, the director of Just Agriculture magazine, and our dear participants to the 19th day of this 21 days international training cum workshop program. Before starting the session, I would like to give a brief introduction of our first speaker of the day to dear participants. That Dr. Pavani Kadyal ma'am, the President GBA, advisor to the board and MS Business from India. She was named as the most inspiring industry leader in 2020-21 by Businessmint in Technology Digital Branding category. Businessmint Nationwide Award nominated ma'am for the most inspiring industry leader 2020-21 in the technology digital branding category in recognition of her efforts. She was chosen for her role due to her hard work efforts which she made to build herself in this level. Businessman feels privileged to honor her award and pleasure to have her on the board. Mem was also honored to receive the award being part of MSME Business from India, board member and a government blockchain association Hyderabad chapter president. As all we are aware, economy development of a nation depends highly on small and medium enterprises. Even the vision of government in India is to make them resilient. That's Atmanirbhar. Working with a firm, ma'am try to assist small and marginal enterprises towards is of doing business by helping them with expert interventions. In the last 3 years, ma'am at the firm have brought transformation in more than 4,000 small and marginal enterprises, sorry, through different support assistance. As a business associated at NetSoft, ma'am informed us that the NetSoft help private enterprises and government agency to solve real life challenges, transform operations, improve customer services, and create new business models by digital technologies. And ma'am usually focus in mainly to bring emerging technology to the best benefit of small and medium enterprises. So would like to welcome our first speaker of the day. Ma'am, please, it's over to you. Thank you, ma'am.
Thank you so much. Thank you, Piyush, for introducing me. Uh, I would like to thank once again Just Agriculture for giving me. This is the second time where I am giving my lecture. Uh, yes, coming to the agriculture, what agriculture is like, as we know, all India complete mostly depend upon the agriculture as we have a very good bandwidth and the people leverages who are mainly working in the agriculture are more than the other sectors, but now people start moving out in the middle of the sectors like coming into the IT sectors and various sectors. Again, now we started back looking into the agriculture using the latest technologies like emerging technologies, what you have mentioned. We have very various examples and exemplary people who left their IT jobs and came back to the field and started growing various crops and varieties of crops in the current scenario and doing so much for the society. As the population increases, definitely the demand of the cultivation is also increased due to as and when we need to have our food for to sustain our lives. So that is the reason agriculture takes very major play role in any country, not only in India, in any country. So that is the reason now people are looking into the technology support, how to improve and maximize the production of the farming at the same time, how to increase the productivity without harmfulness to the production, what we are getting out as an output. Okay, so I just want to share some of my slides, which gives a little presence like what exactly I want to deliver with support of the IT. Can I share the screen?
Yes, ma'am. You can share from your side.
Yeah, thank you. I guess you people are able to visualize my screen,
Yes,
right?
ma'am. It's visible.
Yeah.
Yes.
So, agriculture technology and future scope. Just give me a moment. Yeah. See, like we know in this contemporary world, we have various technologies that are came across the agriculture industry. If you observe the image which I have mentioned on the top, it shows that with a single machine we could able to sprinkle the water as per the requirement to cover maximum level of farming. This has only happened because as we have diversified our technology, we have added the wings to our traditional technology to the modern technology. This is how, like, we can say the manual time consumption is more to cover the land where the farmers wants to cover within a span of 1 hour, the machine can cover in a span of 5 minutes. That is the reason, see, like the technology really helps them and to make them to understand how quick and fast they can work out on that. In India, like we see most of the technologies already bringing into this modern techniques and also generating modern crops, varieties of crops. I can give the best example of dragon fruit. Previously, many people don't know what exactly the dragon fruit is in India. But now the people started eating the dragon fruits, berries, blueberries, red cherries, all the variety kind of food which was getting habituated in the out of the country. Also, we are able to make it happen, the cultivation to be make it happen in our country as well, and we are growing and enjoying the various types of fruits and vegetables. Yes, like as I have mentioned in the previous thing, in the similar way, the machine which you can observe, it is very easy to plow at a times a certain amount of area very easily without getting that much of strain, like and also the animals. For the plowing, mostly the farmers use the animals to work hard, make them to walk all the way and everything. But still, now we have crossed that and we came up with the various improvements in the digital tools and also data as well to collaborate with the farmers as well as the researchers across the area. For this also, I just want to give the best examples. Like in India, in the rural areas also, the farmers are now really going very, I can say, technological way that they are keeping their plowing machines to their bikes on the back and they are driving and making it easy to plow the farms and the agriculture. This is how the technology changes are getting in and impacting even the rural places along with the urbanized. As time passed, we know like technology advances and everything are getting in place, and the tractors are the first and foremost thing which we are mainly using, like from the harvesting equipment, irrigation, and air seeding. As we know, air seeding is nothing but like we are with the help of the machines, we could able to dig the seeds into the soil and make them to grow on time and make the things happens in a particular manner. So, what are the benefits of agriculture technology? One, we will have the enhancements of the crop productivity. There will be a lot of crop productivity in that, and environmental friendly. We are not using any carbon based or something else which we are using only the technology wiring where we can help to grow on time. For this, I can say, like, I guess most of you people know drip irrigation, right? Nowadays, most of the places where we don't have the water facility, we are coming up with the drip irrigation. With the help of the drip irrigation, we can maintain the water level up to the mark of the soil moisturing where the crops or the agriculture can grow. That is the reason the drip irrigation is coming mostly on top to the farmers who are having very less availability of water. In the first slide, with the help of a machine, we could able to cover some part of land in a short span of time instead of a manual person spending a time to just water the complete agriculture land, and the greater efficiencies and price exposure. Even this happens when, see, like, as we all know, if we go with an organic products, definitely the prices are high. And why? Because the availability of the organic products are little demand. As the supply is less and the demand is more, that is the reason the organic products are getting high in demand. So to have more and more organic products, if we use the agriculture technology, definitely we can stand, and where the rates can comparatively come in the similar way. And most of the time we feel to have organic products to be in the final stage instead of having the fertilizer based products and products which we are using. Like, modern technology can be used to improve agriculture. How? Uh, for the storage, mainly the warehouses plays the vital role once the agricultural crop is ready. How this modern technology helps? When once the crop is in hand, we want to store. The warehouses are the primary key role places where we need to store the end product with the temperature sensitivity. Definitely, if we have, because of the climatical changes and the conditions in the current environment, most of the crops are getting disturbed. I can give again a best live example. Recently, from past 2 to 3 weeks, there are heavy rains. Even though it's a month of May, where it is, we call it as summer, still we are facing the heavy rains in the night and morning. It's too sunny. What it exactly happening? It's really hurting the farmers because they are losing their end productivity, as they feel like, yes, the crop is ready to export, but they could not able to store in a perfect warehouse. Their end product is getting damaged. That is the reason the modern technology help. Here we need to have a different kind of communicating things, which I can explain you in the next coming slides so you can understand more in detail. Yes, monitoring and controlling crop irrigation system via smartphone. Nowadays, everyone became smart using the smartphones. Everything can be controlled and observed under the, I can say, cameras, drones, everything where if we want to see the soil moisture or the geolocation of that particular thing, or the crop irrigation growth, how much it has, we can go with the geotagging solutions. What the geotagging solutions do? These geotagging solutions will help you certain area where you are doing your cultivation. It helps to understand what exactly the crop stage is. Is it in a 5 to 10 days or 10 to 15 days, or it is ready to harvest? What exactly the place of harvesting is. So using these kind of systems, definitely monitoring and controlling via smartphones are really becoming easy. A small lightweight of dashboard is provided in the systems so that we can able to control all the crop irrigation using the smartphones. Using mobile technologies and cameras. What happened using the mobile technologies and cameras? As I said, the geotagging really helps them to understand what exactly is happening. At the same time, as the drones are moving in and around, we can also able to control the birds or the animals which are started attacking the farmlands. We can understand that there is some animal is trying to like disturbing the crop. Immediately someone can come on the ground and take care of the crop and make that animal to be away of that. In this way also, like the mobile technology or the cameras in the farming industry definitely helps them. Crop sensors. What exactly the crop sensor is? As I told, the drip irrigation. The drip irrigation is completely under the control of sensors. Once we start going of water, allowing of water through the drips, it will go till the soil get moisture up to the level where we want for that particular crop. Once the soil get moisture to the temperature which it wants to grow for that particular crop year, immediately the sensors will help them to stop that and will help them to avoid extra flow of water to the agricultural lands. This is how we can also like control our water consumption during the agriculture cultivation. Here I have to show one of the modern technology that they are using the sensors. These are some of the types of sensors that will go and will take the real-time scenario of the crops and will give the data analysis. Mostly now, what are the technologies that which we are using in the agriculture industry is one, IoT, sensors, mainly the data analytics, and the crop management. Weather and climatic conditions are also coming under control, but still it is purely like depends upon the nature. So we can able to control only up to certain level, not mostly, because because of this the greenhouses and arranging all these things will really helps them. That is the reason, like if in modern agriculture, if we apply, there is a benefit of acquisition of real-time farm information with the help of all these kind of technology. If we use, farmers need not to spend like most of the time or most of the things, so that they will get the warnings and everything information accordingly. I can say the best example, if you are looking into your laptop, the laptop will show you if we ask for a weather, either a laptop or a mobile, your temperature today is 34 degrees. It may likely rain tomorrow. The predictions for the next coming 3-4 days or 10 days, based on the technology that they use and the application they want to. So based on this, definitely they will have a wonderful scenario to understand, and the growth of the agriculture will be more beneficial to come out of the various hurdles which they are facing. So thank you for that. And now I'm open to take the questions, if any.
Thank you so much, ma'am. Ma'am, may I audible?
Yeah, you are audible.
Am I audible to you, ma'am?
Yes, yes, you are audible. Again, I guess you are in mute. Piyush, you are in mute. Hello.
Yes, ma'am. Now it's okay. Thank you so much, ma'am. Yes, ma'am. Is it audible?
Yeah, it's audible.
Yes, ma'am. Thank you so much for giving a brief and detailed experience of your side. Few of our participants are having some queries. Just a second, I'm seeing in the chat box and will let you know. Just hold.
Sure,
There's
definitely.
some internet interruption here.
Or they can also send it to you. You can bring it to me in an email so I can reply them as well.
Yes, ma'am. One of our participant is asking, ma'am, is there any
Huh.
chances for the new research scholars for having an internship and all the small enterprises for setting a new enterprises? In which
See,
your
again,
firm is providing
internships,
some
internships and
uh,
all, I can say nowadays the government is upcoming with the agricultural hubs in various states under their state and central governments. So my suggestion is, from which state you belongs to, please try in your state where the agriculture hubs are coming up. So you can work with the agriculture hubs and learn more to understand what exactly is happening.
this was the only question, ma'am. There was in the chat box. It was a pleasure to be with you on the virtual podium of Just Agriculture Magazine, ma'am. Thank you for
Thank you
joining
so
us.
much again.
We'll be glad to have you again on some other day.
Definitely, I'm here to support all the time, only using the technologies.
Participants sticking to the session to the next segment. I would like to invite this, ma'am.
Yeah, thank you. I'm leaving. Bye.
Now, the second, yes, ma'am. Thank you, ma'am. Participants, moving to the second segment of today's session, we are having another lecture of from Dr. Gopal Shinde sir. He's project in charge of IDP NAHEP at DFSDA ICR Prabhani, and he will be delivering his lecture with Aruna ma'am. She is professor in computer science and C in Saran Digitech, Hyderabad. So I would like to invite my team for please carry on to the second session.
Good evening.
Arundhati ji have joined us.
Yeah, good evening, sir.
Diksha, you there? Yeah, very good evening. Please carry on with the second.
Yeah. Am I audible?
Yes, you're audible.
Okay. So can I have the host so that I
Diksha,
could
you are
share?
not audible.
Thank you.
Diksha, you are not audible.
I'm sharing my screen.
Am I audible now?
Yeah, you are audible.
Okay, sir. Thank you so much for the previous session. Now I'll carry on with the next session of today. A very good evening to one and all present here. I would like to warmly welcome our guest of honor for the next session, Ma'am Arundhati Pandav Savrikar, Dr. DPS Badwalsa, Organizing Director of this training cum workshop program, committee members, and most importantly, all the participants of this 21-day event. A brief introduction of our today's speaker, Arundhati Ma'am. Ma'am is the director of Saron's Digitech Hyderabad. She is working as a technical consultant at NAHEP VNMKV Prabhani since 2021. She is also the HOD of Computer Science at St. Paul's Degree and PG College, Hyderabad. So we are done with the brief introduction. Ma'am, you can start.
Thank you. Good evening to all dignitaries, participants, students. It's very warm welcome. And I'm sharing my screen for the presentation. Is it visible? Okay.
Yes, ma'am.
Okay, thank you. My topic is agri-tech. Actually, whatever we are trying to show as a smart farming, we are looking for the future of smart farming here. As a computer science engineer, and as we are working in the NAHEP center, and we are trying to execute so many programs and different trying to develop the softwares and apps and working towards the IoT tools and looking for this future of smart farms. So in my presentation, I made it in the two parts. How we can go for the smart farming, and we are looking for the IoT tools, Internet of tools, Internet over the tools in the next generation of agricultures. So first of all, we know that the farmers are putting their all efforts to develop their farming, to sell their products, and then to increase the productivity of their farm. So we are trying to put the technology to reduce their efforts, and they should get the more productivity and the good income through their agricultural land. So this is what the motto of developing all these tools, which we are trying to help the farmers through this. So in this IoT tools, if I'm looking for, then we have the different parts which would be used in the different ways in the farms, in the fields. There are the sensors, then SOCs, microprocessors, then API gateways. How we are using all these IoT tools, I'm trying to briefing on. It's not sufficient to, this time won't be sufficient to explain each and everything, but I'm trying to just briefing on all these things. So sensors, we know sensors could be used in the farms, and then we can write down the program on the sensors to read the humidity or the temperatures, then how much is the rainfall, and different soil moisturizer sensors are there. So this is one of the IoT tool. Then system on chip, we are calling it as a SOC. Microcontrollers can be used for the different high level programming, like the Python programming and Raspberry Pi programming. And then API gateways, this is an application programming interface. By using this application programming interface, we can send the data and store it in the different places. And it is an application programming. Like if I'm sending a data in a simple way, when we are doing the programming, then it is difficult to read the data. So these API gateways will help in the reading of the data in simple way and carrying forward towards the clouds or the database. So this is the interface. And then we have the cloud and analytics. Now clouds are very much, everyone knows, all the students and everyone knows about the cloud. We can say this is a virtual storage. We are storing the data. Everyone is using this Google and maybe the iCloud and AWS. So it is a virtual storage of the data. And we are trying to store the data and then read it. Then what is the difference? If I'll store a data in the database and if I'll store a data on the cloud, then what is the difference? Only the difference is I could access that cloud from anywhere for the analytics, for the analysis purpose. The data could be very accessible through the cloud. That is the use. Now, this is the one of the part that I wanted to tell about the IoT tools. As I said it in the first slide itself, I have divided this presentation in two ways. One is the IoT tools and other one is the smart solutions. In the smart solutions, I tried to take certain, I could say the title of the projects which could be used or done by the students who are in the agricultural education. So there are different kinds of the project which could be done by them. Precision agriculture is there, then crop monitoring, then we can check the livestock of our seeds or crops or whatever we have the different kind of the yield in our farms. Then irrigation management could be done in this smart agriculture. We have the different solutions for this. Then pest control could be done. And the fertilizers management also could be done in this. So I've just tried to categorize this smart solutions in agriculture. If you look at these all smart solutions, then the simple ways are like water level detection can be done with the sensors. As I have shown you in the first slide, the sensors could sense the how much is the water level or the moisturizer in the soil and temperature. All these can be detected by using the sensors, and then it will be displayed on our the results will be displayed on the system by using the programming. So these is temperature can be measured, then humidity could be measured, and wind speed. So this is the first kind of the smart agriculture. This is how we can, I've just tried to put a flow chart how this can be measured. So generally this, sorry, I'm getting the hands raised. So if you have any questions in between, please ask. Shall I continue?
Yes, ma'am. We'll have question answer session in like the
Last. Okay,
last set.
because the participants has raised the hand, so I thought they have the immediate questions. Okay. So this is a temperature sensors are there. What I have tried to show you is the flow chart, how it will work. If I'm trying to put all the systems in my farm, I want to make it as a smart agriculture, then how it will work. So first of all, I have to use these sensors. Temperature sensors are there, water level sensors, then soil sensors should be used. Then it will be controlled by SoC. I just showed that as a system on chip or the microcontrollers. It is a hardware part. And then wireless communication through our Wi-Fi and all, we are reading the data. And then API gateway, application programming interface, we are writing the coding in this API, and then it will be sent to the cloud. And all these activities could be controlled or could be used on our mobile apps. It is that much easy if we are going through all these steps, all this flow chart, and then we can use on this mobile phone. That is the ultimate aim, that user should be, it should be very user friendly, and all farmers could able to use these mobile apps also. Through this mobile app, they are trying to control this all these water levels and They could see the soil moisture sense, how much is the moisturization in the soil and the temperature of the today's temperature and all. So this can be done through the mobile app. So this is what we are looking for. This is what the vision is, that that much simply we have to reach till this end. And that's what I have shown you. This is a flow chart. And the next level is drones for the smart agriculture. As we know, there are nowadays very much discussions, and everybody is very much curious, and they are very much into this drones now. So there's drones has a different applications in the farms. Field monitoring is the most striking feature of the drones. Like if you have a large lands and the farms, and you cannot go till the end, then you cannot observe each and every corner of your land, then it is very much used by the drones. And the diagnostic of your diseases, the pest which is there on this farms and all, that can be also done by the drones. And the same way, the flowchart has been shown. There should be, we have to use the cameras on the drone, and then the chip will be there, which will be the interface. It will be catching out the data from the camera, and then through our Wi-Fi we will get the data. Then we will write down the APIs, and then through our mobile we could see what exactly is happening in the farms. So these are the different applications of the drones, or we can say the advantages of the drones in agriculture. It is a wide application, and we could just use all these application at a time. So I just wanted to show you, once we have executed one Python coding, and we took the trial on this coding with the drone, that we have detected the pest. So I'll just show you how it will be seen and how the coding can be written. It's not the programming that I'm trying to display, but the output of this drone trials I would like to share with you people. Just I'll show you how it will be. This is the Python coding which we have tried it on the drone, and we got the images. This was the actually input. This was the images which were there at the database side. After flying out with the drone, and we got the pest detected like this. So this is the image from our drone directly. It shows which is the paste, and how much is the accuracy of the space, because what we got is the data on the drone was like this, and then it has detected the paste in this way. To detect this paste, actually, I must say we need a lots of images. We almost collected the data for almost thousands of the images with the different angles, with the different cameras, and then we could detect this caterpillar on the maize field actually. So this is what the drone trials has been already done, and then we are now looking for the next drone trials also. Coming to the presentation. These are the different applications of the drone, which I said just now. And now this is the next level of smart farming, which will be used by the all farmers, and it will be at the next level is a robotic arm, or the robots could be used in agriculture. Even though it sounds a little bit difficult how we will use the robots, but we can use these robots very easily in the farms. And on that robot, we can fixture with the different cameras, and then it will have the different sensors which will detect the obstacles while it will be running through the fields and all. Then we could post on that different harvesting tools, and definitely we need the SOCs, system on chip, with the different robotic arms. And then we'll capture the data from here, and through wireless communication and APIs, then we could use it with our mobile app. This is nowadays what we could see, and it's very much in the talk that the all robots, robotic arm can be used for the harvesting. Then it will be inspecting your fields, whether your fruits are ready, or what exactly going on in the field. And then seeding, like we know the grafting robots are very much into it nowadays. And then the sorting and the packing of different kinds of the yields in our farms. This is also can be used by the robots. So this is what very briefly I wanted to say with this agri-tech. And now I just wanted to share one more thing, that in this NAHEP, as I said, the mobile apps, through mobile apps, we could do so many IoTs, and we could use it very easily. So we have developed a few apps which could be used for the weather detection, and forewarning models are there, and it has been used in the Play Store, and even for the weed detections and the pest this pest control also we are developing the different apps. So I'll just share a simple video of this app. It is available in the Play Store. This is the weather detection, or we could say it will predict the weather, and it is available in all the languages. This has been used by the farmers so that they could know the weather condition, and which crops has to be used, or which kind of the herbicides has to be used in their fields. Everything could be detected, everything could be predicted with this app. So we could say it is an agrometro app. It is predicting with the weather, and then rainfall, and all these parameters, Tmax and all we have taken. Wind speed also could be predicted. And if you'll click on any of the crop, then it will suggest what to do for this crop in this season also. So we have the chat in this. The farmers can send their queries, and then they can ask any of their doubts, and then immediately they will get reply on their phones. So this is what is a part of the IoT tools that we are trying to develop. This is already, as I said, available on the Play Store. And it's available on all 3 languages. Now this is the suggestion, this is the advisory for that particular crop, what to be done if the condition of the farmers or the condition of the weather is like this, then what to be done. That advisory has been given over there. Okay. So this is what supposed to explain, and my presentation of the agri-tech. Now here I'm yes.
Yes. Thank you so much, ma'am, for this educative session. Now we'll have a brief questionnaire round. I will read out some questions.
Okay.
The first question is, what are the best ways to foster trust in smart farming?
What are the best ways
to foster trust in smart farming?
Oh, can say it's very much like we can go with the smart farming, and will be with the best part we can use all the sensors and the different kinds of the IoTs, and then they can be used with the different people and programmers for them.
Okay, ma'am. Ma'am, next question. How, according to you, is IoT shaping the future of farming?
It's really changing the view of the farmers also. They need all the information to be used very handy. They are willing to be seen these all information on their app, and everything should be in a closed way. So it really we are looking for in these 1 or 2 years it will be change the farming ways also.
Okay, ma'am. Next question. What goals should smart farming serve, or what goals are there which smart farming should reach?
Basically, really, I wanted to ask the students and even the faculties that they should support us. We are really the technical people, so they should support us. They should tell us what are the problems they are facing when in the research or actual in the ground level. According to it, we can develop a different kind of the scenarios, and then we can show them how it will be work and how it will be useful.
Okay, ma'am. Ma'am, next question. How can data be understood by different verges of people?
Data will be in the different formats. So when we are developing it in the apps or in the different communicative medias, then it's very simple. That's why we are trying to put it in a regional languages. Then English also for the researchers, for the faculties, it should be used. So it's an understandable image or the text format. It is very simple.
Okay, ma'am. Ma'am, question. How is the acceptability of this app among the farmers?
Yeah, it's a very good response that we are getting from the farmers actually. They are because they are that's what I said. They are looking for the help, technical help. Because they want to depend on themselves rather than if somebody is suggesting. When they could see the weather, they could see the temperature, then they can decide on themselves what to plow and what to do exactly in the farm. So it's a very good support and the response from the farmer side. They're really happy with this technology nowadays.
Okay, ma'am. Any questions from the participant side? You can ask. Two people had raised their hands.
Okay.
Yes, Dr. Ayushi. You can ask the questions in the chat box as well. Ma'am, what are some of the cons and pros of IoT?
If I'll say, mostly I could see the advantages because it will reduce the human efforts and Disadvantages are like definitely we have to be a little bit dependent on the phones and the simple things like whether we have downloaded the apps and whether it is working properly, the connectivity, all these might be the problems. But really from my side, I could see all the advantages. If we could identify the proper problem from the farmers, then definitely it will be the advantages.
Okay, ma'am. So I guess these are the questions for today, for this session.
I got one more question. If
Okay.
someone has asked that we could provide any internship program. So these programs already, as we are working, this company is working as a technical consultant at the NAHEP and KB Parvani. So we are conducting all these programs over there also. So you can contact over there and then you can have all those internship programs there.
Okay, ma'am. Thank you so much, ma'am, for this brief yet educative session. It was a very informative session, and we are very grateful to have you, ma'am. Thank you for giving us your time.
Yeah, thank you so much.
Thank you so much, ma'am. Now moving on to the next session, we have Dr. Gopal Yushinde with us. For the next session. Dr. Gopal Yushinde, he is the principal investigator at NAHEP, DFSRDA, VNMKV Center. Sir is the director and principal of SHJ Polytechnic Institute, Mumbai. Sir also has a vast academic experience as a professor and visiting faculty in various institutes of India. Sir has also published his works in various national as well as international proceedings. So we are done with the introduction. So you can continue.
Very good evening. Am I audible?
Yes, sir.
Yeah. A very good evening, and this is opportunistically we are meeting again at the platform of Just Agriculture. And before starting our technical discussion, I like to have a virtual tour of this NAHP center. Specifically, I like to mention it over here that the center is funded by World Bank. And this project is aiming to make the digital technology applications in all over India for the Indian farming society to explore with the automation in agricultural system. The project is introducing you the activities of the 3 applicant devices such as agricultural robots, agricultural drones, agricultural AGVs. AGV is nothing but automatic guided vehicle. These 3 device applicants as of mechatronics field, we are gathered the different interdisciplinary approach in the agricultural university system scenario, that the participating scientists will be of different discipline. For example, entomology, pathology, agronomy, soil sciences, then the different types of the agronomic conditions, agronomy, and so on so far. The different applicant devices which are to be nurtured by the artificial intelligence, and this artificial intelligence will be developed by the professors of the different disciplines. The data that has been explored by physical exercises, and till this moment, I should say the past 4 to 5 decades, when we have automation at a very primary level and the intervention of these different types of automation systems and devices, that has been explored to the exhaustive trials, and the agricultural university scientific research database now is need to be explored for the development of automated system devices such as a robot, drones, and automatic guided vehicles according to the Indian cropping system. According to the Indian system of those all the agricultural activities that are to be performed by using the automation system. No doubt, everywhere the expenditure, think tank, and database. These all activities are need to be performed. So, central government of India is exploring the funds, and they are going to give us a facility platform through this NAHEP center, which is a National Agricultural Higher Education Project. And under this National Higher Education Project, here
Sir, you are not audible.
according to the affordable class of the farming society. So I just like to proceed with the presentation part, and I just have to mention it over here that I am going to first of all deliver you the virtual tour of this center, and this center will be giving you the entire physical accessories and resources which are available at this moment. So I just make it this as a part of discussion, and there are two devices now. We are turning around the center so as to see by the applicant, those all participants who are really like to know by the virtual presence of all those devices which are facilitated from this center, and we are developing also the different kinds of devices. So at this juncture, we have another device with us. I will like to mention it over that this different types of devices will be shown to you by another device, which is I'm going to just explore it from this center. So this specific activity that we are going to present it over here, they are nothing but the agricultural robots, and related to the different kinds of the Indian cropping system. For example, cotton picker machine, which is automatic guided vehicle. For example, the cotton picking robot. We call agricultural drone as agri drone, and we call agricultural automated guided vehicle as agricultural agri AGV. So these three attractive the interest of the youth farmers, which we are going to present it for here, that I'm going to show you. I think we are on the line with another device. Mr. Tanzim? You can share. And then let's share. Thank you. Now we are at the automatic weather station. Mr. Gopal Runner, can you share your mobile device, which will be seen by everyone? Yeah, that's good. That's good. Now we are taking our virtual tour to see that the various types of Mr. Rane. We are on the line with another device, and here we can see. Am I audible?
Yes, sir.
Yeah. So as the network issue is maybe somewhere fluctuating, but I'll just like to show you with the device from Gopal in Rane. Gopal Rane share kara patkan. Now here you will see that the automatic weather station which is required, because we are having a separate portfolio, that is a climate based decision knowledge support center. Climate is one of the important factors for the farmers who are always in search of getting the weather situation, and accordingly the whatever the changes that he needs to do in the field, that is going to be transformed to the automated device systems. शायद मैं कभी-कभी हिंदी में भी आपसे बात करना चाहूंगा, क्योंकि इसमें बहुत से ऐसे सिस्टम टेक्निकल चीजें हैं जो आपको जल्दी समझ में आए. ये वेदर स्टेशन जिसमें टेम्परेचर, मॉइस्चर, जैसे कि जमीन में एनपीके, ये सारे these all kinds of the factors which we need to develop and show it to the different technical system design. For those all receiving data, that data is going to process, and further that data will be helpful to make the all kinds of operational changes, and according to the need of the database requirement, the farming activities like a robot or maybe drone or maybe AGVs who are in need of these all climate based knowledge, and accordingly the system will be developed. Mr. Dr. Aniket Vaikar and Engineer Vishwa Pratap, are you able to hear me? Engineer Vishwa Pratap. Engineer Vishwa Pratap. Engineer Vishwa Pratap and Aniket. Mr. Gopal Raner, you make the camera close and immediately you have only 3 minutes to explain, and immediately go to the next center.
Okay.
Come on, make it fast.
These are different sensors which are for climate environmental parameters measurement, such as temperature, humidity, air temperature, air humidity, and PAR, photosynthetically active radiation. And soil moisture sensors is installed here. This is the 1.2 meter soil moisture, 1.2 meter length of this soil moisture sensor, and it is having a data logger of CR 1000X model. The data can be easily obtained by using the USB cable to mobile device or any type of computer or laptop for analysis of different climatic parameters for different crop health monitoring conditions. Thank you.
So this can be one of the very much informative think tank for a field like our university. We have a 7,000 acre land, and we may be able to make monitoring and getting this all information to transfer to the device. So we can develop IoT tools. The main thing is that to develop an IoT tool, which will be a practicing research work by the PG and PhD students of agriculture university. the students are aiming to make different kinds of sensors and their application studies with which one can understand how climate is one of the responsive domain for the different kinds of agricultural production activities. We are making this all kinds of the activities to present. Before that, without a smart portable machinery or without automation by mechanism, it is not possible. So we have a scissor lift for the automation system, and the particular specialty of this scissor lift is that it can lift up to the 30 feet of distance, where the large trees and different kinds of insects, different kinds of the pests, which are white grubs, beetles, they are making their attacks on the big plants and shredding all leaves. They are eating and destroying the kinds of the plant health condition. So we are having the such facility of the spraying system. This is a remote control device that we are developed, and further to this development, we are going to develop a robotic arm which will be helpful for the big trees to get spray and get health protection. And also the same device can be turned out to the 15 or above feet of height operations, wherein the pruning kind of actions will be able to get help of doing these operations. So Tanzim, can you explain immediately and quickly? You go to the next machine. Gopal Raner, move it fast to Tanzim.
Hello, am I audible?
Mr. Gopal Raner.
Am I audible, sir? Unmute kar. Hello. Hello.
Yes.
Audible.
Yes, you are audible.
Sir, this is a scissor lift which are having a 4 blade and 1000 kg loading capacity, and it has power pack and 100 ampere battery. It can be operated on wire and wireless remote control. As you can see, this is a we have make it on a portable, on a vehicle mounted, and for the spraying purpose, we have a 1000 liter capacity tank over here. And it can achieve a height up to 20 feet, where the above high altitude and above height work we can easily done by this vehicle mounted scissor lift. That's it, sir. Thank you.
So going to the next part.
Yes, sir. Yes, sir. I am audible, sir.
Yes, explain.
Sir, this is a vehicle mounted refrigeration van, which is a 2 ton of cooling capacity. And the application of this reefer van is transportation of seedlings, vegetables for the long journey, and it can keep that fruit and vegetables and flowers and all for the 8 to 12 hour fresh. And this is also mobile operated temperature adjustment system we made, sir. By using the mobile operated application, we can kept a temperature from from -20 Celsius to 24 degrees Celsius temperature. And now we are going in the farm machinery workshop, sir.
Go ahead, quick. Chalo, next. Go quick. Now this is a smart farm machinery workshop.
Solar and battery operated solar machine. It has given a 40 liters tank capacity, and it can be operated by manually and mobile operated. Hello, sir. Hello. It has given 4 nozzles, and you can operate it by manually and mobile operated. It has given the 360-degree movable camera. We can control the plant from the wild animals. I will start this. We can start this forward and backward also. Now I will start spraying and movement also. It has given the sound buzzer system, so can the plant can be protected from the wild animals. Next, this is the garlic planter. You can in the 1 hours 265 plants can be planted by these machines. It can be operated by the mobile also. Now it is remote operated. Next, we are going to develop is operated by mobile. It is also operated by the solar and battery. It has given the 12-volt battery. Next, sir, this is the cotton picking machines. It is also operated by the solar and battery charging. I will start this. This is the, it has given. The collection of cotton behind this machine. There is a tank.
I will like to add some of the things that this center has developed. The cotton picking machine, which can be affordable for the small farmers. Here you will see that a pneumatic suction pressure is designed and developed by the NAHEP center. The cup that is holding the pneumatic pressure, that pneumatic pressure is designed with the help of a CAD/CAM lab and the mechatronics lab, which is aiming to make this the perfection that if there are leaves or if there is a dust or if there is any obstacle coming across the cotton, that can be rolled out through the filter process, and this machine can pick around 150 to 200 kg of cotton per day. And the tank which is being provided in this machine is of 15 kg capacity. Within 1 hour, it is 15 kg capacity of the cotton which is being picked up by the farmer. The farmer is a single operator, and the machine provides facility by use of the solar system and the battery system. The charging unit is made such that a farmer can do different kinds of electronic applications. He can charge the mobile, he can play the music, he can also work in the night hours time by using the solar flashlight. And the most easiest and comfortableness is that a woman labor for cotton picking can also use this device, and she can pick up the cotton as of the higher side as a manual fatigue, which is coming up as a problem from the farming society. This has been resolved. The cost of such a machine can be up to 90,000 rupees if we go for the mass production. If anybody wants to make this product affordable, then we have a client manufacturers, those who can take up this machine. And another device that is of higher side is a cotton picking robot. This is a cotton picking robot, as our engineer Dr. Shivanand Shipuja is showing, that we have made the robot in combination in different application wise, requirement wise this device in collaboration with the Globomac. You will see that there are two arms, and these arms having a camera systems, as well as the arm which is working on the basis of electrical energy sources. It will pick up the cotton and it will drop into the box which is provided there. So you will see that these two boxes wherein the cotton is get picked up and it is dropped into that. But the only part of importance is that this device is working out wholly automatic manner. Go to the next. Go to the next device. Quick. This is an entire workshop. We have a facility of making different kinds of the custom robots, and this will be going to make another, the kinds of research platform for those all engineers working, studying in this university campus. I'm finding that the students who are working here, they are coming and they are doing their practices of experimenting different kinds of devices, and the resources that we have facilitated here. We have a tractor also. That tractor is we are aiming to make fully automatic, and this tractor will be giving you all IoT tool for the operator. Every farmer needs to know that how much of the acres of land it has been worked out for the day out operation, and for this day out operation, how much is the charge that is important, and that charge is mentioned it in the IoT tool. So this attraction before the farming society, and they will look at the kinds of the developments, and further to that, we are also interested to make this part as one of the interesting for, and we are trying to start the different kinds of trainings to be provided for the researcher students as well as farmers. So we are developing different kinds of automated planting system machine, maybe applied with the 17 HP tractor. So just going to the next part, I like to make mention it over here that we are trying to develop the indigenous agricultural operation based agricultural robots, agricultural drones, agricultural automated guided vehicles. So we have different divisions, and food processing automation center is one of the attraction. So if you go to the food processing automation, the kinds of development such as we are developing this machine which is a 3D food 3D extrusion food printer. We can see that the 3D extrusion food printer which is developed such that on mobile it can be operated. So Shweta, can you explain?
Yes, sir.
Start explaining quick.
This is 3D extrusion food printer. So of this we have different 6 type of products: chakli, shevaya, purode, and these are the different products. And this machine is operated by Android app. From this we adjust the setting of the different products, and this machine now will start.
You can see
Yes,
on the mobile itself there are different operations. Start. If you start, press the start button, it will start doing operation. And there are 3 axes of motion: x-axis, y-axis, and z. Z is the feeding action, which is lifting up and down. So according to the feed and the system. Shweta, continue.
Yes, sir. These are the products, and this machine have capacity at least 8 to 7 kg per hour. This is the working of the machine. Thank you.
Now, just stay with there for the drones. Stay there for the drone. I'm just now showing it to you, drone. See, this is the sprayer drone, and it is nowadays as an attraction of the youth farmer. Everyone likes to know how this drone becomes a toy, a choiceable toy for the youth farmer. They want to do the operation of spraying. They want to do the different kinds of operations at field operation at the farm, different kinds of activities also. This is a 10 liter capacity of the pesticide tank, and it holds the pesticide of different kinds with their different solutions. It is just like a proportionate pesticide solutions. Agricultural scientists, they decide how much and what quantity with their percentage ratio contribution with the water get mixed up. This drone is working on the principle of the gravitational force, which is taken up by use of this the brushless DC motors. We call it as a BLDC motor. There are 4 arms, there are 6 arms, there are 8 arms. We call them as the quadra means 4, hexa means 6, and octa means 8. So whenever there are arms which are mentioned with these fins and the kinds of the development that we are going to make, I think Gopal, you stay with only one device. I will just explain first sprayer drone. मैं ये सारे ड्रोन्स को आपको बता दूंगा, किंतु यहाँ पे जो स्प्रेयर वाला ड्रोन है जिसमें जीपीएस सिस्टम है, can you show Jyoti the GPS system? Yeah, this is a GPS system which will locate the positions, coordinates in the field where you like to know the exact traveling path of the drone in the field. You make a path, traveler's path for this drone and get it registered, because the drone related associated rules and regulations are now being very strict and broad, to such extent that if it is a heavy drone, you have to take first of all training, get license and become a pilot, and then you can go for opting this the scheme, central government scheme, where you can purchase the drone and you can make these operations for your higher on systems, or maybe as a self owner. The pendant, which is can you show the pendant, Jyoti ma'am? Yeah, remote. Show the remote. Show that remote. Yeah, this is the remote wherein you are supposed to hold with the kinds of buttons and their knob systems with a wireless kind of connectivity, and you can connect, you can attach the mobile, and the mobile will hold the software operational, all kinds of the recordings. The recording which is for the drone, when it travels, it can take a picture, it can take a traveler's path, it can show you all those informations from the airways. So aerial robotics is also another name of this drone. We also call it as an unmanned aerial vehicle. The brushless DC motors, they are designed according to the payload capacity. When we like to lift up, suppose for example, the 10 liters capacity of this drone, for which different kinds of these brushless motors we define, and nowadays the researchers are practicing to lift up 200 even kg of the weight to be lifted up. The drones with the different kinds of nozzles, the drones with the different kinds of cameras, you will see that the camera and their systems we are developing at our center. This camera, earlier it was supposed to fixed up with the open head kind, which will drop, maybe committing, if we commit any accident, that may damage the lens of the camera. So in our center, we have a 3D printer. So our students, our technical staff, they are developing this, the safeguards of the camera. And this camera with the safeguard will take care of this camera to not to damage, or if there is any accident, it will preserve. This is a parrot sequel camera, which is we are using in the field system, where just now our earliest national consultant for the software, Pandav Saurikar ma'am, has explained about these softwares and how they are developing different kinds of logical tools such that it will be helpful to the farmers easily. So for which this camera is a eye vision, and it detects various types of images and accordingly develops the logic that what the operations is to be performed by use of the automated machines. There are different kinds of drones with their all kinds of structures. For example, parachute. This is a parachute kinds of a drone. When there is any failure in the air, the parachute will automatically open, and it will give you that protection to this drone not to damage, because every component is a very sensitized and it is delicate. If there is any wind pressure comes across or maybe any change, and certainly it inserts to the cyclone, the damages to this drone should not happen. We have developments of different kinds of this drone designs at our center. DJI Phantom is also one of the popular drone, which is we are every time using in the different marriage functions, and the cameras which are used to get the images to be captured in various types of difficult places where human cannot reach, and these different kinds of images and their logical interpretation can be done with the help of this DJI Phantom kinds of drone. The development of such drones and their accessories as electronics component manufacturing system scenario. Now government is giving us one of the resource, financial funding resource, and the backup support, technical support to develop different kinds of such drones in India. We have a very small 3D printer also for the student experiments. Students can perform the experiment, and you'll see that the students will get learn of it works in 3 axes of motion direction: x-axis, y-axis, z-axis, and there is a hopper system. So nowadays our ICAR students are making their experiments to develop. Suppose, for example, on a cake you want to print some name, or suppose there is a mixture of different components and you want to design out your cake or pasta or maybe pizza or maybe different kinds of food articles, wherein the attraction in the market to make the value addition, you are supposed to go for such a new technology which will be helpful to the small group of even those entrepreneurs who are interested to enter into the digital food printing system. So the 3D footprint, 3D printers we have in our laboratory, and our students will go for developing their own 3D printers, and those all things we are looking at around. This is in the drone lab and the food processing automation center. Now we are turning to the mechatronics lab and hydraulic pneumatics lab, where all the facilities which will be explained by Apurva Deshmukh. And Apurva, you can start and get explain of these all facilities, and you will be continued by the Vishwa Pratap Jadhav and also Jyoti. You can start. Yeah. Apurva and Aniket, both of you, your voice is not clear.
Yeah.
Apurva, you can start. Your voice is not clear.
These are multi-spectral cameras and LiDAR cameras for different types of pest, plant disease identification at the early stage. So we can control the attack of pest or attack of any diseases. This is a parrot camera. This is having 4 bands, red, RGB and NIR band. for different types of images. This is the MicaSense camera, MicaSense Red Edge MX for different drone image calculation like vegetation indices like NDVI, vegetation condition assessment, and different types of crop health monitoring purpose. This is the spectroradiometer for identification of different spectral signatures of different types of crops according to their vegetation conditions from sowing to harvesting. There are different types of parameters in this software: ICAR, CIE, CME, CRI, PAR, and the graph is shown by the different wavelength, and this is the absorbent indication. This is a lux pad. These are different parameters that measured by this spectroradiometer. This is the LIDAR camera for robot application. We have different types of robot. We can mount this camera on the robot, and we can monitor the different fields.
Yeah, definitely. The solar system, nowadays attraction to the solar devices. Apurva will explain the solar system devices, how to design and develop.
Good evening all. This is a solar energy unit. We place this unit for the research and study of the PG PhD student. With the help of this unit, we can, with the help of, here is a regulator, we can adjust the illumination, and by adjusting illumination, we can see the changes in the temperature, voltage, and current. Now I am increasing the illumination. When I am increase the illumination, the module temperature means its temperature will increase. Likewise, here are the some black plates. We can hide the solar PV cells, and by hiding, we can also see the difference in the temperature and voltage. So by this, student can understand how much energy can be generated by each panel. We can also put on one panel and calculate the energy, and when by using both panels, we can see the extra energy, increase in the energy.
Definitely, students are interested to now turn to the solar system as well as the sensors application. So the next is the sensors. You have a different kinds of sensors, and the sensor studies are very much essentially required by the agricultural students nowadays. Apurva, continue.
This is a programmable logic unit. Now we have developed one module for PLC. By using this PLC, we can write one program for depending on our application. Suppose we want to harvest one fruit, then we can write a program in this PLC, and we can take one sensor, and from that sensor, like image processing, by using the camera, we can harvest that fruit. These are the different sensors, different switches. This is the encoder, rotary encoder is there. This is a switch for this encoder. This is a timer and counter. This is a motor. And this is a wireless transmitter for giving wireless supply to this by making IoT for this sensor.
Now we are going to the SCADA system. We are going to the industry 4.0, but we are now interested to introduce our young researcher to turn to the agricultural 4.0. So agricultural 4.0 and there are IoT system, Wi-Fi system. Jyoti, you can start explaining.
Okay, so industry, it is a model of virtual machine industry 4.0 for the student purposes. Here we consist of the two stations, station 1 and station 2. In your practical or actual implementation, you can use number of stations. So how the automation is takes place in the industries for showing such type of operation, these two stations or this virtual machine is used. It is used by PG and PG students for the study purposes. So here I had given an order to check whether the job is perfect or it has to be rejected. So that is sorted or differentiated by using this machine. This is pneumatic-based machine. This robotic arm and complete machine is 90% operated by the pneumatic energy and 10% operated by the electric energy. This operation can be performed by using the mobile phone from the remote distance. If the job is okay, then it's processed by both the stations. If the job is rejected, then it is processed by only single station and given to the rejected section. This job is okay, therefore it is processing by both the stations. And then this complete process can be observed by using the SCADA version. On this monitor, the SCADA version of this complete virtual machine is available. From this SCADA version, where the job is located can be detected. Or you can observe the complete process by using this SCADA version. This complete process can be used by using mobile IoT monitoring. Here, IoT monitoring is also possible, in which you can observe this all SCADA version on your own mobile and can be operated from remote distance.
I like to just request Dr. Aniket Vaikar can be co-host due to the battery low problem. And before that, I just like to mention it over here that we are holding the different kinds of divisions. As I mentioned, we have agriculture robot, agriculture drone, agriculture AGV, and more than that, we have a 3D scanning, 3D printing, and the most important attraction of this center. I'm just going to I'm making unshare, and then Dr. Aniket Vaikar, can you make it yourself sharing this all videos, and quickly we will finish because I have to present other things, and we have to also interact with the participant.
These are different types of sensors.
Continue.
Soil temperature, soil humidity, and this is the data, portable data logger, from which we can directly access the data by using our mobile or pen drive.
So this is the sorter. The sorter makes the differences of the different colors, different compositions of the material which is to be sorted and separated. Vishwa Pratap, can you explain?
This is an object sorting machine. It can sort metallic and non-metallic objects. It is a totally automatic system. We are using here PLC and some sensors, just like optical proximity sensors, inductive proximity sensor. Basically, optical proximity sensor is used for metallic and non-metallic object detection purpose. So, and this is our inductive proximity sensor. It can sense metallic objects. As per detection of this object, it sensor gives signal to PLC, and PLC will give command to this cylinder so that object will sort automatically. So we can also modify this into color based object sorting system. It can use in our agriculture system also for separation of different types of foods. This is
Go to the next.
This is a pneumatic control panel, control system. So this is a totally study purpose. We are using this for the study purpose for our PGPhD student. So here this is a double acting pneumatic cylinder and some sensors, pneumatic sensors, just like limit switches. So as per the design here, 10 to 20 practical for students for their learning purpose. So this is a self electropneumatic system. In electropneumatic system, they are using PLC with our pneumatic equipment. This is a hydraulic control panel. So in this hydraulic control panel, they are using different types of motors, different types of cylinders for study purpose. Then this is a PLC. This is a electric PLC. So this panel is a electro-pneumatic panel, electro-hydraulic panel. Thank you.
Now, different kinds of the pneumatic hydraulic systems and developments by the student is one of the main attraction. And you can see now what are the digital services and platforms, website, IoT tools, and all those students who wants to learn from distance, and all those digital e-Diksha, and we have kinds of coordination, operations, and collaborations with the different premier institutions and all over the globe. We have more than 21 country professor faculties who are joined. Engineer Sanjeevani is looking after the computing system, computers, and the softwares and tools students are learning. She already took so many workshops and the trainings with our team to develop different kinds of softwares. Saran digital consultant, and then another different types of consultants who are working with this system here in this campus for the students' research and project developments. So, Sanjali, can you continue? Make it fast.
Yes, sir. Sir, this is the website. In that website, we are continuously updating the contents, whatever the
Your voice is low.
This is my website, and there we are doing the 3 academic courses: Agri-Drone, Agri-AGVs, and Agri-Robots. There are the 2 main parts, short-term and long-term. When we go to this link, the student registration form is open, and from the June we are starting the academic courses. Student can register from here. Next one, the Python module we have developed here. This is one of the Python module which is used to calculate the number of apples on the tree. This is the sample image we have taken, and from this code, this will calculate the number of apples are present on the tree. The second module is flower counting. This is the Intel RealSense camera we have used to detect the object, and by using this camera, this image is captured a real-time image. And from this, it will be converted into the grayscale format, and this is the output for this particular image. The second one is object detection. This is the setup for our module, and from this, we can get the output and the distance of the particular things or tomato from the particular location of the camera. This is spectroradiometer camera, which is used to further student research data analysis purpose. From this camera, we have calculated the different parameters for the student research purpose. Thank you, sir.
Yeah, very nice. The students can join. I request all the participants to enter into vnmkv.org.in. The website address is https://nahep.vnmkv.org.in. Now we are turning to the next part, which is a very much attraction of the center, and the different national scientific dignitaries visited to this center. They have seen the activities of the robot and robotic system, automatic guided vehicle systems, the kinds of software like CAD/CAM software, ANSYS, and their developments, and digital classrooms, virtual classroom, which is now a attraction to every student, that if they miss any class, if they want to join a class from national wide, all the experts from different faculties, from different universities, they can join. We have made such a facility over here. Now let us go to the grafting robot. Grafting robot is one of the attraction wherein the two kinds of plants join together. Just like, for example, a brinjal and tomato. Brinjal and tomato, it will become a brinjato. Then potato and tomato, it will become a pomato. So kinds of different kinds of a hybrid, the grafting where the cucurbitaceae, solanaceae families, vegetable crops. We are also making our researchers practices towards the medicinal plants, towards horticultural plants, like mangoes, different kinds, like citrus fruits and their plants with the different kinds of facilities to be provided here. The grafting robot, I mean to say, Dr. Aniket, can you go to the grafting robot section? Okay, he's going till then. Before that, I'll just like to mention it for you that the grafting robot is having a capacity of 2 plants to graft together. The root stock and the scion part is the half below and half above portion of these 2 plants. It selects a root stock of one plant and the another part, which is scion, and the root stock and scions get clipped up by use of the cutting and the joining mechanism. So this will be helpful for the grafting of the different plants. We are not only grafted, we are just transplanted to the field, and we have got the results for the who are changing their properties. I mean, where the properties are changed by the different kinds of products that we have developed. For example, brinjato, we got a brinjal kinds of root stock, and the tomato as a scion. So the tomato grown up with a very hard stock root support that has been grown up with a very much different kinds of characteristics or properties. We have another device here, 3D scanner, and we have also the another device that is a 3D printer. So this 3D printer, 3D scanner, they are the attraction, and you can see till the connectivity comes back with the another device. I like to just show you some of the highlights. So if you can see that as I mentioned, that there are different kinds of portfolios and 3 divisions: agri-boat, agri-drone, agri-AGV. These are the main attractions of all over India to make an applicant device, mechatronic device applicants. And this way you can have a participation of the metrology professor scientist, then agronomy professor scientist, pathology professor scientist, genetic professor scientist, then different horticultural professor scientists to work into the scenario where the climate is very important. You have different kinds of sensors and their applications to make the participatory all those. Now I request to see that I'm going to unshare. Okay, I'm going to unshare now. It is shared with the grafting robots. You can see the plant. Mr. Farooq, can you reproduce again the one more plant? Repeat. Yes. Can you repeat so that all participants will see how this grafting robot works? We have taken one as a rootstock, another as a scion. So from right hand side there is tomato, from left hand side it is a brinjal. So brinjals, rootstock, and the tomato scion, they got joined together and become one plant. This is the attraction. And it grows, the mortality is a 98%, so that the plants which is seen, you will see surprisingly, we can produce 800 plants per hour. And if it considers 8 hours of plant shift, you can see Around 5,000 precisely the plants can be produced. Thank you, Dr. Hemant Rokde, Dr. Farooq Bari. You are showing these grafting activities. The different participants can make their participation through joining our 3 different courses. We have started for PG and PhD students, we have started professional certificate courses. Here is the robot. From Canada, we have taken this jackal and husky. Engineer Ravi Kumar Kalloji will explain you about this jackal and husky.
It can be operated by RAS programming. And we can also mount robotic arm. We can also
can you show 3D printed robotic arm?
Platform and for fruit picking and cotton ball picking, like that operation we can do. The same way, this is a jackal husky robot. It can carry up to 30 kg payload.
See, this is engineer Ravi Kumar Kalloji will show you the different components, how they are printed out, and that becomes a robot arm.
These are the 3D
can you assemble the robot arm
on this jackal husky robot?
Can you assemble the robot arm? Assemble.
These are different kinds of.
Can you assemble the robot arm and show it that how it becomes a single assembly
components?
रोबोट आर्म को ज्वाइन करके दिखा एक बार. See, this is the 3D printing mechanism.
3D printer, we are printing 3D prints of different robotic arms, whatever are required. Yeah, this is the 3D printer. We are printing different types of robotic components as per the requirement. And just we seen that in robot husky robot. In that husky robot, we are printing the components here for testing purpose, and we are printing different kind of components like robotic arms and drone propellers and different kinds of strings and nozzles. These are the components we are printing for research purpose.
I like to mention it over here. Engineer Ravi Kumar Kalloji, can you assemble? Engineer Ravi Kumar Kalloji, can you go to the next lab? Before that, I will just like to say that students are dreaming. They are making their different kinds of software designs in this lab, and this is a very much important sensitized software. You can make the live object, like all those components, get them assembled, prepare the whole object and get it tested by simulation. The simulation is the main attraction. You can see the component, a planter, this jackal husky and all the students are need to study to prepare them individually. सभी कंपोनेंट्स अलग अलग बना के उसको असेंबल करते हैं. असेंबल के बाद उसको टेस्ट करते हैं. हम टेस्ट करने के लिए सारे लोडिंग पैरामीटर्स देते हैं, बाउंड्री कंडीशंस देते हैं. द मेन अट्रैक्शन बिहाइंड दिस इज सेंटर इज दैट the students are learning, self-learning with these different kinds of softwares, how to prepare different designs, different component design, different robotic arm design, different drone design, drone component design, and individual component will be assessed. इंडिविजुअल कंपोनेंट को असेंबल करने के बाद, फंक्शनली कार्यरत करने के बाद उस पर क्या असर होते हैं, वो काउंट्स हम सिमुलेशन द्वारा यहाँ पे ज्ञात करते हैं, जिससे हमें पता चलता है कि एवरी कंपोनेंट्स पे कौन से असर होते हैं. जो असर देने वाले सारे लोडिंग फैक्टर्स को हम बाउंड्री कंडीशंस दे करके हम उसका एनालिसिस करते हैं. It is very much amazing thing that the students, you see this is a planter, you can see the live object. उसका प्लांटर दिखाइए रवि कुमार कल्लू जी, उधर बाजू रखा है. शो दैट, पिक अप दैट एंड show that. See, it is like a tailor is doing operation, making measurements, cutting and stitching. The student is also sitting at CAD/CAM lab and he is measuring every dimension of the every component, and is get prepared into the design with the help of our team. Engineer Gopal Raner is one of the group scientists, Dr. under Ravi Kumar Kalloji, who is making this team entirely boost up to get the every drawing, design, dimensional features and making them individual parts, assembling, and after getting this tested into the software, they are going to produce a real object by use of maybe either 3D printer, by use of either our the smart farm machinery kitchen. We have developed the different kinds of the small components. You know, the engineers like students who are developing the smart sprinkler systems, smart pop-up sprinkler systems, and they're getting print out and then get it immediately test to the field. Suppose there is a plant like a flowering plants, we have suppose for example a rose. Suppose there is a flower like maybe orchid plants. So if we go for different kinds of plants, these different kinds of plants will have their different canopy. And this different canopy will hold their geometric structure. According to that, we try to develop the sprinkler or maybe the nozzle, which will spray as according to the fountain that we require. And once it is get dreamed, it is designed, and then it is get print out. And once it is get print out through 3D printer, it is get tested. And once it is tested, the student can go for a copyright. Student can go for different kinds of patents also. So I'm very much proud to say that the team, entire NAHEP team, with 18 engineers of different faculty, different disciplines, electronics engineering, mechanical engineering, then instrumentation engineering, then production, the agriculture engineering, food engineering. We have different kinds of technical staff also who are looking after the technical operations, like to run the drones. And you know, the various types of possibilities that has been made facilitated to the students. कोई भी चीज अगर डिफिकल्ट तरीके से आपके सामने आती है तो उसका रिवर्स इंजीनियरिंग करके भी वो स्टूडेंट पढ़ाई कर सकता है. He can do the technical aspect studies. You'll see that every kind of the knowledge gain system is been facilitated by this NAHP, CAST, DFS, RDS, VNMKV Center. This is a CAD/CAM laboratory facility which has become a all over world renowned to get introduced by our Indian cropping system, where our Indian agriculture system, where the various components, various machineries, various kinds of design and development, as well as the simulation. Even it may be a matter of soil and water conservation, it may be a matter of the irrigation system, agriculture process engineering system, food technology, farm machinery, design and developments, or it may be any non-conventional, conventional energy sources. We can do the structural analysis, we can do cumulative fluid dynamics analysis, fluid flow analysis, electromagnetic analysis, we can do vibrational analysis, thermal analysis. There are various kinds of things that students need to learn in the easiest possible way. So we are also running different types of courses from this center. You can join by always connecting to the website. You'll get information from time to time that this center is aiming to make the e-learn platform. And this way you can join different kinds of activities. We are inviting the students of who have completed PG or PhD for joining 3 professional certificate courses. This is the virtual classroom platform, Agri Diksha, the virtual classroom, or you can say webcast channel for the agri students, aspirants who can go for learning different kinds of national, international level, these different courses, different kinds of the teachers who likes, the student who likes can join, or the faculty who likes to make the participation with the student from the Indian contest. This is virtual classroom, Agri Diksha. I'm very much thankful to Dr. R.C. Agrawal, sir, National Director, Government of India, our National Coordinator, Anuradha Agrawal, Madam, and you can say the team from the University campus, Honorable Vice Chancellor, the former Vice Chancellor, Dr. Ashok Dhawan sir, Present Vice Chancellor, Dr. Evely sir, our Dean and Director of Instruction, Dr. Gokhale, our Director of Research, Vaska, Director of Extension, Devasarkar sir, our all 20 mentor team members, core team members, those who are day-night working with us, our NAHEP team staff also day-night working with us. You'll see that every kind of facility is been provided. Now it's up to the student how much of extent he can become elastic and yield to earn and gain the knowledge from this center. We have a different kinds of digital library facility for the student who can go for making their different types of research practices by using the digital literature publications. You can see the different international journals, the digital books series, and you can also participate with the IIT professors. From IIT Kharagpur, Honorable Director V.K. Tiwari sir is also helping us. He is a first initiator to make the IIT and this VNMKV participating center. Then Dr. Machavaram, Dr. Dev, Dr. Alok Kanti Bhattacharya ji, Mahua Bhattacharya ji, and the faculties from IIT Bombay, Dr. Amit Arora, Dr. Satish Agnihotri, Dr. Penan Chinnaswamy, Dr. Udmalay, Dr. Kavi Arya sir. We are developing K Yantra, that is one of the new attraction. We are also associated with Washington State University, USA, University at Polytechnic Valencia. Dr. Francisco Rivera, who is a chairman of the All Over World Agriculture Robotics Society of European Commission. We have connections with the Florida University. We have connection, mutual research work with universities from Australia, different universities from different countries, University of Putra, Malaysia. You can see that the different countries and their faculty participation will be definitely boosting to the Indian all participants as well as the national, international student participants. Today I'm here to make this delivery and discussions about this center. However, the presentation will be, you will see that the different kinds of things that I'm going to just show you. However, the different kinds of this presentation will be also available on the platform, like our website, which we have developed. You can have different kinds of tutorials, then courses to learn. With your self-registration, you can register on our website, https://nahep.vnmkv.org.in. The attraction behind is that we are not only aiming to see and learn the developed technologies, but at the same time, we are also aiming to make our indigenous technology to nurture to such an extent that farmers will be offered and accept. The GIS system, GPS systems, geological modeling systems lab also is going to develop here by the IIT Bombay. And also we are developing the different 3D fruit printer, different kinds of agricultural grafting, robotic systems, different kinds of small portable smart machineries. We are also developing small tools, small kinds of the operational devices for agricultural farm machining society, and making this as an aim to get extreme end of the remote and remote-most place. If the farmer is satisfied, then we will feel that our all efforts are contributed to this nation. Dedicatedly, the aim of this all practices with the national pride that the farming society should become digitally alert. And this digital alertness will definitely come up by gaining the knowledge from the education system. So that's why the National Agriculture Higher Education Project, which is given to us, and this is a prestigious project and exclusively for knowing how the digital technologies like robots, drones, different electronics, mechatronics based applicant devices, how do we can design them, how do we can analyze them, how do we can produce them, and to make such a sustainable development, the entire system will work for the different kinds of activities and their plans. So no doubt the team from VNMKV, Vasantrao Naik Marathwada Agriculture University campus, and our the team members from different disciplines, they will be contributing for this center to make the presentable outcome, and that will be from lab to land, as the Governor of Maharashtra, Honorable Koshyari ji, instructed and happily blessed us to say that every technology will come up to the farming society, means your victory, your efforts are get fully justifying to the state prideful nation services. We are having different kinds of university as well as different kinds of researcher organizations from Japan, from different kinds of countries like Switzerland, Malaysia, Thailand, and also from European countries, France, the Portugal, Spain, and different kinds of universities where we visited and made their participating with our all aiming objects. We have also developed NOPED, solar-based NOPED, with the help of the Aryan digital technologies, and going to get the help to the small farmers for their preserving milk. Also doing the same moped application for the small operations in the field. Electronic heads and the different kinds of small developments will get boosting to the farmers, that he will not feel alone, and he'll not feel a labor scaredness, because the developments kinds of facilities that we are going to provide them. And we are also aiming to make the farmers to get know every knowledge, every kind of knowledge from the field on his palm top or maybe a mobile or laptop, that he will let know what is happening in the field. So all those design developments, then plant population counter, fruit population counter, is an attraction to the new society, and definitely one who is understanding this will definitely like to participate in the digital agriculture farming society of the India. So I pray every one of you to join with us, to connect with us, and let us have your registration, your kinds of a participation with our portal address, that is https://nahep.vnmkv.org.in. Our simple address is vnmkv.org.in. So different kinds of feedbacks, your questions, your all kinds of those queries will definitely going to connect and fulfill with satisfaction. I'm very much happy and thankful to the Just Agriculture organization, especially Utkarsha, Badwalji, and all of their team members who are taking a very grand successful efforts to participate from all over India, from all over globe, or from different countries. And this will be definitely going to make one of the new harshful, participative, attractive, and all kinds of knowledge and platform to the society of Indian agriculture system. I'm very happy that this today's discussion, whatever we have gone through with our team members, I'm going to just say thankful to every one of those who are participated and will be connecting to us. So thank you one and all. I'm open to all of you for the further discussion.
Thank you so much, sir. Now we'll have a brief questionnaire session. I'll read out some of the questions.
Please.
Yes, sir. So the first question, how is the global agriculture industry impacted by the introduction of agriculture drones and robots?
Nowadays, as the attraction of the drones, which is aiming to make the two kinds of activities, such as a spraying operation, and another is a scouting operation. Spraying operation, which was earlier conducted by the manual, or maybe the pump, which is supported, and it may be also tractor mounted, or maybe power tiller type of a system device operated. But the kind of application by use of a drone, and then Government of India is facilitated with the kinds of subsidies, or maybe this is a support to the youth farmers who can participate through the drone application system. So this is going to be impact. This is going to say influence over the youth farming society, and also the society who needs these kind of applications, because the harms to be handling by the human beings. Nearness to the spraying system is causing harms to the health condition or health hazardous situations by the farmers. Now it has been eliminated, rather minimized by distance operating device. Another thing is that farmers like to know the different kinds of diseases. So if he knows the diseases, then immediately he can take over the action for making the pest application. So like pest detection, pest control operations is very much essential. Third thing that we are making aim to attract this society to make the plant population counter. Suppose farmers को अपने मोबाइल पे पता होना चाहिए कि मेरे फील्ड में आज कितना प्लांट्स है, मेरे फील्ड में आज कितना fruits है. I like to farmers, being a farmer who likes to know how many plants are there in his field, how many fruits are there in his field. And if there is a system like he knows that 10,500 plants are there and 50,700 fruits are there, every fruits is get numbered, every plants is get numbered through this digital system. And if any fruit is get infected or any plant is get infected, the number of that plant or fruit of that plant will be get immediately flashed to his mobile, and he will let to know that position where the insect has started infecting the plants. So there he can take immediate initiating action. For the robot, the robot will take the position to that GPS system to go in that exact position and get spray of this only pesticide to that location, so that it will minimize the wastage of the pesticides. So main attraction in these three kinds of the regards, as I mentioned, it will definitely going to impact those who are doing their operations. It may be for the large farming operations, or it may be middle, or maybe sometimes where the labor scarcity is there for small farmers.
Okay, sir. So next question. What are the limitations of agriculture sensors?
Yeah, agricultural sensors, the soil sensors, which is very much attraction. Nowadays, the soil sensor is required for every farmer to know the health condition of the soil. If he knows the health condition of soil, the sensors need to be produced. So IIT Kanpur, IIT Kharagpur, they are developing the different cheap kind of sensors which can be tabulated, which can be constructed to the device, which will be easily the farmers can offer and get applied over there. Maybe it is like sometimes farmers like to know the temperature of soil. So farmers like to know the moisture in the soil, or maybe environment, or maybe like to, because we are working in the three domains, entire environment, then below soil surface domain, second domain, and third is the plant and its surrounding in inherent maybe inside the plant health condition monitoring. So with these all sensors are required. So sensors are going to affect. If the sensors are giving exact information, you need to make the calibration perfectly for those sensors who are deriving the relationship. And according to that relationship, you'll be like to know what is that all parameters that has to be understood by the farmers, and accordingly he has to act. So census impact is that kind is a basic things which is touching to the foundation of the digital technology automation establishment in the automation system of the agriculture.
Right, sir. So the last question, what role will robots play in the future of agriculture?
See, the different developed countries, their universities I visited, I saw their experiences, because we, after all, from India also, we are trying to rush for the kinds of such a development which will be affordable by mass farming society. And the farming society, because in India, the labor scarcity is not there, but the kinds of efforts, kinds of operations, and then automation system is one of the most important likelihood, the kinds of requirement by the farming society. So robot will go for picking for fruits, robot will go for spraying operations, robot will go for the kinds of scouting, pest detection, even robot will be make different kinds of field operations, post-harvesting operations, and it will be helpful to the farmer as a friend. And if it is Pictorially, you are just observing it as a toy. Pictorially, you are observing it as such a machine which will, now it has become a humanoid also. Or in Boston Dynamics, they have developed a dog-like the robot, which is going to the field and scouting and turning around the whole field area and giving you the information. So the time, when the time is very important factor, the robots will help. When there is a hectic, repetitive kind, fatigue-full, those kind of a working activities in the field operation, their robot will work. Hazardous situations where the different kinds of difficulties for human being to reach into that particular part of the operation, the robot will work. Then robot will work to the extent of the human kind of intelligence. When human beings are developing their artificial intelligence, the kinds of all those activities will be dropped down to the electronics, mechatronics, and the certain, you can say, the operational software programming, which will understood by the machine, and machine will operate accordingly. The highest version is that the humanoid robot, which is nowadays been practiced by different countries. So I just not say discourage that the robot will minimize the, it will unemploy the laborers. But rather I should say computer, when it was entered, that time also it was said the unemployment fear. But now I should say every human being from India particularly, or from all over globe, should understand what is the technology that is going to help you in this automation system. And if he knows very well, then he will be acquiring that knowledge to operate. So intelligence is required, skill is required, and if once a human is acquired this all knowledge, he'll be sustainable and happily make this kind of participation in increasing the productivity by digital farming solution and going the higher economy of the nation. It has to be nurtured for every Indian farmers from India.
Okay, sir. So thank you so much, sir. It was an amazing session, and thank you so much, sir, for satisfying the queries as well. It was an amazing session as we could see for ourselves the working mechanism of all the machines, and it was lovely to have you, sir. Hope to meet you again in the future. Thank you so much, sir.
Diksha, can you take all of the participants, let us ask them to make their camera on and make the screenshots of all those participants, so that it will be a memorable to say that every client is very important to us for Just Agriculture as well as the NAHEP Center.
Okay, sir.
I will request all the participants to make your video cameras on, and let us have this photo session. Let us have this photo session of this event, and we will keep this photo session to our website also, and try to make everybody to communicate in future for the best possible solution from our center. Thanks to organizers, thanks to one and all, and the senior dignitaries will bless this center to make their participation for the researcher students to develop. I think from Diksha, your side, you can make someone to take
yes,
the screenshots, and let us hope that the 200 participants, I could see their picture, I could make them communicate, and you can have our website access with all the detailed informations. Everyone can participate, and our all NAHEP team staff members are ready to help you in this regard.
The participants can open their video camera. So we have already taken the screenshot and we'll share it with you, sir.
Thank you. Thank you, one and all. Let us be with our digital farming society of this nation, and I'm very happy to invite you all to visit our center also. Thank you.
Thank you so much, sir.
Thank you.
For the next session, I would like to call upon Himani ma'am to take over.
Thank you, Diksha. Thank you so much. A very good evening to all of you, and it was indeed a very wonderful session. We all enjoyed the session very much, and I just want to thank Shinde sir for that. And now taking the program to the next segment, I would like to invite our next guest of the evening, Dr. Subrat Panda. So Dr. Subrat Panda is the CTO of Agnext Technologies, which is focusing on delivering technologies to ensure quality food for billions. The technology focus in Agnext has been at the trifecta of data, IoT, and artificial intelligence and solving the quality issues for the food value chains, thereby saving time and money for the customer. Prior to that, he was the VP of Engineering, AI and Data Sciences in Capillary Technologies, which is a SaaS company in the retail space with a presence in India, China, Southeast Asia, and Europe, Middle East, and Africa region, where he led the AI team working on smart store and personalization. He did the bachelor's and PhD in computer science from the Indian Institute of Technology, Kharagpur, and he has worked with Sanops, IBM, STG, NVIDIA, and Taro, which is a Bay Area-based food tech startup. He has also worked as a research consultant on various industry-sponsored projects in SRIC, IIT Kharagpur, and he is also an author to industry sponsored projects in SRIC, IIT Kharagpur, and he is an author of multiple patents and publications in international journals and conferences. He is a technology advisor and a mentor to multiple startups in multiple domains. So it is our pleasure to have you, sir, and it is my firm belief that your experience will teach us a lot today. And now over to you, sir. The virtual podium is all yours.
Thank you. Thank you, Himani, for the wonderful introduction. I'm humbled. So I'll start off with, I think my presentation. So I'll share my screen. You need to tell me whether it's visible or not. My screen visible? I hope it is.
Yeah, sir, your screen is visible. Kindly make it full screen.
Yeah, sure. So, is it visible now? You need to tell me, because sometimes these things.
Yeah, sir, it's visible.
Okay, perfect. So, what I would talk about is, since I have my expertise is in AI and building products, I would like to talk to the forum here about how do we apply AI to agriculture. So it's about building products. Thank you, Just Agriculture, for this opportunity. I think Himani has done the bit here, so I won't spend time here introducing myself. So what we do at Agnext, right? So we do, our mission is quality food for billions. And how do we make it possible? We do a lot of research on methodologies and analysis, all data oriented. We build products using AI, IoT, and a lot of software centered around data. We work in a lot of commodities. You can take tea, coffee, grains, oils, milk. We do work on all of those. What do we use to, or what in tech do we use? We use an AI spectroscopy. We work on computer vision, machine learning, deep learning based algorithms. We build our custom hardware. Hardware without software is kind of useless, right? So we do a lot of automation and software flows around them. And the most important thing today, which we deliver to customers, is building traceability, which is, it says, where has your product come from, right? Where is it coming from, and the source. If you know which farm it came from, which date it was packed, nothing better than that, satisfying than that. One of the most, our North Star has been, can we do quality analysis faster, cheaper, with business acceptable accuracy, right? That is the core of our business. And this is where we use a lot of AI and data. I'll talk about that. But I hope I've been able to tell you that, we are committed to bring in quality food to your plate, right? So how do we make it happen? we make it happen. We have our computer vision based solutions. We have devices. We have molecular spectral devices. And then we have on-edge IoT, right, where we try to the device in itself is complete enough to do the analysis and give you the results. For example, if you say, I'll give a small example, right? Whenever somebody is procuring wheat, an organization or is procuring wheat, or a buyer is procuring wheat from a farmer, he would do the analysis at two levels. One is the looking at the moisture level, moisture content of wheat, and looking at the physical, structure of wheat, or the texture rather, right? Which is like saying how much is damaged, how much is broken, how much is shriveled, how much is rebuilt, right? So all these are taken into consideration. These are based on chemical properties, as in moisture, and some are based on physical properties like the appearances, right? So what we have done, if you do a typical oven test or other test for finding out moisture, it's a tardy process, right? We have found out easier methods for them. You take the sample, put in the device, you get the moisture in a minute, right? So we do the same thing with physical, where we have a scanner, we put in the, we call it the spec video device, right? We put in the grains there on top of it, and then you get the results. This is where, if you look at this device, this is what does. This is a device for tea leaves. This is the device where you can do moisture for grains and protein, fiber, oil content, sand silica, all that, like within a minute or two. This is the device which we use for spices, and this is where the algorithms that we have used. You use a lot of AI algorithms using data that you've collected from multiple places, multiple time period of the year, and we go ahead and build them over time and deploy them on the devices that we have built, right? So bit what the agri-tech, right? So agriculture, this is definition, formal definition from Wikipedia that I try to figure out, right? So agricultural technology or agrotechnology is the use of technology in agriculture or any of those horticulture and aquaculture, right, with the aim of improving yield, efficiency, and profitability. We have done the same. We have tried to, the entire quality assurance piece, which is the core of our business. We have tried to build it using technology so that it becomes faster, cheaper, and more profitable for the end user, right? Which is a more efficient process. In fact, this is where you kind of don't use chemicals and all that stuff, leading to lesser use of greenhouse gases and all that, right? Literally, so you become more greener and sustainable over time. A few examples of this is, we all know about drones today. They are very popular. We have satellite photography and sensors. We have IoT-based sensor networks, face tracking, weather forecast. You take any of these all have a very strong impact on improving the yield, efficiency, and profitability, right? And, we have soil moisture sensors, hydroponics, soilless farming technology, a lot of these things. And, so soil is a very important thing. We all know about it. I don't know whether you guys are aware of it or not, but there's this thing called Save Soil campaign, which is being run by Sadhguru from Isha Foundation. He's driving across countries from Europe to India and talking about the importance of soil, right? And if you know what quality of soil is within a minute, you know what action to take, right? So that its nutrient value, organic content value, all that is in the limits for you to get better yield, right? So, so that's agri-tech, right? So we knew what agri-tech is. Now let's talk about a bit of about AI and data, and then see how we build a product around this. So AI primarily has been, the precursor to AI was analytics, where you tried to see what has happened, right? And this is what it was, descriptive analytics. What happened? Then you will go to diagnostic analytics, and why did it happen? I mean, what are the reasons or the markers, or why? What can I do to prevent it primarily, which can happen later, right? Which is once you know the factors important, you can do that. Then predictive analytics, what will happen given the current condition, what could happen, right? And the prescriptive is how can we make it happen, right? So this is what so this is hindsight, whatever happened in the past, you try to get some input on that. Then the insight, right, which is once you know the factors important, then you can predict what could happen because these factors are present. Then foresight is something where you actually predicting far into the future, saying that, okay, this is how we can make it happen, and this is how we can prevent it also, right? So analytics have been very strong. AI has the journey of AI has been to make sure that all these things which analytics gives you, right? Analytics is very, very people driven or a process driven thing, right? AI is trying to tell you that what can be, and like you say, right, AI has to be automatic. It's the acme of automation, which is like any human being that we can talk of, right? So AI's journey is from, so for a device, let's say you want to make it AI enabled, right? It should be able to take decisions like you. It should be able to sense things from the environment and act immediately, right? And that's what AI is all about. So we have to see how we can apply that in agriculture. By the time that I've given some examples, I would have got some, I think you would have got some sense of it. But so the way that AI has progressed over time, see, the entire thing around intelligence is called AI, right? Where you are trying to build algorithms to simulate the human mind or human intelligence, it's called AI. Machine learning is a part of it, which is actually started off, AI started off in the early 1950s, then 1980s is where machine learning came into picture. You're trying to do the feature engineering, or you're trying to actually do a lot of things. You feed it to a system, and then you get some output. AI can be various types. We'll talk about that. But just for the sake of starters, we have ML here, and then we have DL here. DL is deep learning, which is a subpart of machine learning, which is simulating the human brain, right? Just by mimicking the neurons, which is basically a set of equations which act like the neuron in the most idealistic way possible, right? So this is how AI has been. Deep learning, I think anyone who has been interested in working in AI knows what deep learning is, right? And I've taken it from NVIDIA, this slide. So now let's talk about a bit about what machine learning typically is, right? So machine learning has three versions or three classes. First class is supervised learning, where it is called supervised because you have labels with data, right? So it's called supervised. You have unsupervised learning where you don't have any labels with data, you just have data, and then you have to figure out what that means, right? Then you have reinforcement learning, which is, this is the branch of science or machine learning which is the closest to what a human mind thinks like. So even in supervised learning, you have something called classifications, where this is like the images, and then you have to you say whether it's a cat or a dog or a car or a bus, things like that. Then you have regression, where you have to predict a number. It's a continuous thing, right? So looking at my face, can you predict my age, right? Similarly, in unsupervised learning, you have the problem of clustering, where given data of similar types, they will be clustered into groups, right? And then dimensionality reduction is where there is a lot of data, a lot of columns, but the columns so that you can do meaningful analysis. By virtue of removing the columns which are correlated, and there are a lot of ways to do that. I won't go into depth of that, but this is the most upcoming area of reinforcement learning, of machine learning, which is very important, which is very relevant from the aspect of human-driven intelligence, right? So I'm a big fan of this man. He's Andrew Ng. He says that he's one of the gods of machine learning, right? There's a concept in machine learning called transfer learning, and which he says is the next big driver of success. And anyone working in ML, AI, or DL, he knows what he says, right? So what it means is you learn in one domain and then apply it to another, see, this happens in humans a lot, right? For example, any equation that I've learned in maths, it's a differential equation, right? There's a very strong application of that in physics, in this laws of motion. So you're actually applying your knowledge in one domain to another domain. And this is what transfer learning is all about in AI, which says that, okay, can I apply my learned knowledge till now into another domain, right? And for example, if I have a deep learning network or a model which has learned images, I can actually go ahead and kind of fine tune it to some fine classifications, right? Which is called which is used in transfer learning, which depends on the scale of data. We won't go details of this, but imagine that you learn something and then you're applying it to other domain, right? And that's possible in machine learning. Again, this says what are the success drivers of human success. Today, supervised learning is the most important one which is used. This was 2016, but things have changed now. Reinforcement learning has got a lot of adoption. Transfer learning has got a lot more adoption today. Unsupervised learning is still there. I think people, we see there are a lot of things like auto encoders and all that which come up and which do keep a lot of usage in unsupervised learning. Reinforcement learning is why you see today companies like DeepMind coming up with a lot of new things, right? The AlphaGo game, if you have learned about, it's all based on reinforcement learning. So yeah, so this is what the drivers of ML success are, right? And if we look at things today on what machine learning can do today is about, given a picture, are there human faces, right? You already see that in Facebook or LinkedIn and not LinkedIn, but other social Google Photos and stuff like that. Given loan applicants, what is their credibility? Right? That's all done through AI, machine learning primarily. Then, whom do you show an ad, right? That depends on the clickability of that ad for that particular person. Right? Then, can you transcript an audio clip? Can be done today, online. That too. Right? Translation can be done at the same speed as as we speak or as you write. Census from so there is something called concept called digital twin that is being made today, which is actually an AI model of the entire system, and that can tell when can a particular thing go bad, right? So you're doing preventive maintenance. Then there are car camera and other sensors, a lot of things, self-driving cars are today possible, right? I think I would like to add one picture here on, AI, when and giving a similarity of how human beings grow, right? So we grow, well, the first thing that we see is through our eyes. I mean, I will say the feed is through eyes. The first sensory perception that we have is through eyes. We recognize our mom, dad. The sense of touch is already there. Then, we recognize them slowly. But we take a lot of time to make a coherent statement, as in speaking. So voice is hard, audio is a bit harder, but vision is fast, right? So today we see, we see self-driving cars today. We'll be seeing other things also on the voice and NLP side. We have made a lot of progress. Then once we have that, then the other perceptions will come into picture, or smell. E-nose are today we have some technology called e-nose, e-tongue to have the sense of taste and smell, which can be built to mimic the taste and smell thing, right? So yeah, things will come up, and it will be able to cover the entire gamut of the sensory perception that we have. Then we will have a humanoid maybe someday. So then now that we know what AI can or cannot do, we should figure out when am I ready to adopt AI. Right? So first of all, can the use case be enhanced by the use of AI? So you shouldn't jump into AI just because AI is there. Then because AI is a bit probabilistic, there are multiple classes that things can fall into. Should I go ahead and am I comfortable with that nature of AI solutions? Do I have enough data? is the bang per buck on that is spent in building the AI-based solutioning worthy of investment? And there's always a timeline required to improve and iterate with any AI product. Do you have that timeline? If not, then I don't think you should go ahead and adopt AI. So a typical cycle of the entire process is you have data acquisition, data push ingestion, data curation, model building, production deployment, right? So this is a cycle that an AI product, and there's a cycles around this, right? You go ahead and kind of deploy and see what's happening, deploy and see what's happening, right? So you use a lot of sensors to collect data, then you clean the data and organize the data, right? And if required, this is where you save data so that data governance is taken care of. You then build a model, typically an ensemble model is built, and then you interpret, right? Available dashboards, or find out what's happening. Is the accuracy good enough, bad enough, or what is happening, right? This is the cycle that is adopted for AI deployment. Now, how did we apply it to? We applied it to we applied it to a lot of things, but I would talk about something where we impacted farmers. So we had the inbound lots of chili here. We had a setup here. We got data transfer to the secure server and to Qualix thing. Then there is a physical computer vision. So you spread the chili, physical chili, and then you know what quality it is of, right? It is easily integrable with software suite, real-time approval, disapproval of supervised level, and secure encrypted data that we have. I would like to give you guys a demo of that. So this is the image of this thing happening on the field, right? So I don't know whether you can hear the audio, but I will try to do this. This is where the report comes in, and you are good to go, right? So it's a very simple product. You can deploy it anywhere in the field. Go ahead and check the solution and deploy it, right? And it could be done in collection centers or in the farm. So we have to look at whether applying AI here would make sense or not. It did make sense, right? Because of the scale, because of a lot of other things. We had the weighing machine integrated with things, and then it used to work seamlessly. So I'll talk a little bit about the new frontiers of AI, reinforcement learning and GANs, right? So reinforcement learning is that area of AI where you're trying to learn from an environment. So this is not related to agriculture. What I'm going to talk right now is no way related to agriculture, but I thought it would be interesting to talk about it here, right? So you have an agent. When you take an action, you either get a reward or a punishment, right? Which is typically, you can say it, right? I mean, if you're a kid, I typically give this example of you see a stove and then there's something burning on top or something getting heated on top of it. You go and touch it, you feel hot. Next time you don't touch it, right? You do a good action, somebody rewards you, this is a good action, right? So we know what it is, right? So we learn with time, with experience. And then there is a lot of concept of exploitation, exploration. We won't talk about that here. But I would just talk to you about that, AlphaGo is the game which was developed by, I think, DeepMind, which I think it did beat Lee Sedol the world champion in Go, right? And this was because they had taken the videos of AlphaGo, him playing of Lee Sedol playing games. It was learned from the images that what are the best possible next step for every step, right? And then it eventually bet him down, right? So yes. Then there are GANs. I think these are generative adversarial networks, which actually try to generate data based on an input distribution, and they're very good at data. I mean, generating data. You can generate a lot of data. This is useful when you don't have data. If you guys are interested, you can reach out to me. I can help explain that. In the interest of time, I won't talk a lot more on that. So this is another person to follow, Jan LeCun, who is the director of Facebook AI, or rather Meta AI now. He says that GANs is the most interesting idea in the last 10 years in machine learning. Amazing thing, right? I mean, you should look at it. This is how we human beings also operate, right? We look at data and then try to figure out whether it's a concept which I find very innovative. Leave out this thing I don't want to talk about. So I just give a demo of what is my screen visible. I'm not sure it is.
No, sir, it's not visible yet.
Okay, one second. I'll stop sharing.
Yeah, now it was visible and then you just stopped.
No, I'll just. Okay. Sorry, there's a.
Yeah, it's visible, sir.
Okay, so this is the first, CNN example. This is Jan LeCun himself, showing how digits were identified. Look at it. It's a printed checkbook or written letters, right? And the digits are getting identified, right? Positioned in the same location where they found the digits. So this is how, and this is a very old piece, right? It's able to identify things like really fast. Right? This is part of his, I think, PhD thesis or something. Right? So amazing things, right? I mean, things have happened over time. It didn't reach. This is a very interesting piece. See, it's very this handwriting is different, right? The 4 and 6 are different, but it's able to correctly identify. So it will be able to do this one as well. So these are all good things to see. I don't I'm a big fan of tech, so I always talk about how has tech helped, right? And then this is something that
you've been such a leader for deep learning for so long. Thanks a lot for doing this with us.
Well, thanks for.
So you've been working on neural nets for a long time. I'd love to hear your personal story. How did you get started in AI? How did you end up working with neural networks?
Sorry. So this is another one where I think I should. Okay, that's perfect. Look at how the robot learns to walk. So yeah, I think so the application areas we know about, a lot of things that can be applied on. We can apply it on vision, speech, agriculture, finance industry, healthcare, retail, supply chain, aerospace, and thank you. I hope I was able to give you guys a view of how we can apply AI to agriculture, right? And with the small product, and also give you an idea of what AI can do, right? So thank you.
Thank you, sir. Thank you for this wonderful talk. And we have some questions from the participants. So if you allow
Sure.
me, then
Sure,
yeah.
sure. Please.
The question is, please elaborate about AI, ML, and DL and how we can use it in agriculture.
Right. So see, when the example that I showed, right, the example on chili that we've done, right? So what we did is we took images of chili, right, and of multiple types. We built a deep learning, which we chose a good network, a deep learning network. We used that network to train that model. We used a pre-trained model and did transfer learning on top of that. And then we went ahead and firstly we did it for desktops. Then we went figured it out how to run it and on the field, right, using a mobile phone. Right? That's where you take the image, you first send it to the backend, and then it was the last version is it's actually running on the device. Right? So it was a very good application where you first collected data, chose the algorithm to be run for classification, and then run it from on the chili model.
Okay, sir. Sir, another question is how AI is helpful for disease and pest management in a better way than the traditional methods.
Right. So I think today, if you look at it's a very you can look at this, that when a disease or any kind of pest infestation happens, how do you know whether what kind of pest is it and what is the action to be taken on top of that, right? So you can take a picture of that, and somebody, there are a lot of companies today coming out with what is this, what kind of pest is this, right? I can do a classification of that and then also suggest you that you should use this to fix this, right? That is one use case. But also there are multiple use cases where you can say that I can even start predicting, given data from previous years and the current trends, that you should be careful that pest infestation can happen, right? So do this preventive measure even before the pest comes in.
So, as we know, or we are experiencing the climate change right now,
Right,
and the pest status, the disease status, everything is changing every year. So
Correct.
if we talk about we will see the data of previous years, and then we will predict the attack of disease and pests. Then the pest status is changing every year. So how do you see it? How
Good
AI
point.
can be helpful in this regard?
Very good point, right? So see, AI is a good predictor, right, in the sense that it can give you some trends looking at past data. The new knowledge of things that can come up, we can have those kind of nuts and bolts into our algorithms which can help us predict the anomalies. For example, this is the hottest year that we have seen, right? And then we know what correlates with, if the temperatures go so high, what correlation can happen, right? We have already, maybe we would have seen a few spikes the few years earlier, or maybe 10 years down the line. We could have seen what were the correlative factors that come with higher temperatures, right? Then try to predict them given the current state. So this requires specific modeling, which can give us, these kind of probable things that can happen because of this high temperature. And then use that to proactively prevent damage.
Okay, sir. Sir, one other question, like in which parts of our country, India, AgNext is operating?
So we have operations across all the states in India, I would say. I think most of the states we do operating. Most of the states. We do procurement for a lot of state and central government agencies. We are working with big time corporates as well, right? Lucky enough to be in that space across India.
Okay, sir. Sir, do AgNext provide any kind of internship or hands-on training opportunities to the agriculture graduates?
Yes, definitely. Please reach out to me.
Sir, how the students or the participants can go for it? Can you please tell them for their knowledge?
You can send us an email at I would say careers@agnext.in. Careers or recruitment.
That will be very helpful for all of you.
Yes.
Sir, another question I just want to ask that AgNext is working in the field of food for enhancing the food quality and security. So likewise, you know that in today's time we are facing many problems like the presence of heavy metals or the pesticide, fungicide residues in the food, and for predicting that or for detecting that residues, we are using the techniques, chromatography techniques, like we are using HPLCs, and nowadays we are using GCMS, MS, LCMS, MS. So what do you think that in coming future, how AI can do this work?
Yes, very good, right? I think this is a very interesting question, right? So AI is AI can do that, but you also need a sensor, right? Today, any experiment that you do is in the lab, right? You go and do that HPLC test or the GCMS test or whatever that is, right? To get those results and verify. You have to have an equivalent technology which can kind of sense them without doing the experiment. So that's building the sensor is the first thing. You see the point, right? And then first sensing and then building the AI with the sensor catches, right? With the data that the sensor catches, you have to build an AI model on top of that. And then make the sensor or the device intelligent enough that it is able to decipher, depending on the value extracted, that this is this or this is not this, right? Decision making capabilities. So that's
it will take time. We have to make sensors for every pesticide, for every metal, heavy metal, and then we can move further. Yeah, sir, that's very informative. And another question I just want to ask, like, you know, the Indian scenario, you know about the Indian farmers also. There is a section of farmers who don't listen to the scientist, even if they are asking them to use something natural and that will cause a reduction in their yield. They just beat them also, even they can do this thing. So you know the scenario of India and Indian farmers. So how do you see the scope of this technology in India? How we can just tell farmers to go for it? Would it be easy, or would it be in the research only?
No. It will be available to people, and I think it's all about consciousness. I think there are 3 levels of any technology or anything of this sort. I have realized that anything of this sort to make an impact requires 3 things. One thing is policy level changes, which the government has to push. The second thing is an awareness at ground level on why is this thing important, right? And third thing is technology providers like us who provide technology to make this thing happen. Right? It requires a 3-pronged approach, right? So the government and NGOs and people working at ground level should be conscious, which farmers FPOs, they should be conscious that, and who can make them conscious? The people on the ground who are consuming, right? Then technology adoption will be rapid. Without that, it is going to be slow. But yes, the collective consciousness that we all have around food, we all want to eat good food, right? That should be the biggest driver for this to happen.
Okay, sir. Sir, AgNext is working in the food quality, and I have heard about the traceability. So what kind of traceability, like from where we have taken the food item, or like what? I just want to know.
Right. So for example, today transparency is the biggest thing that anyone likes, isn't it? You would like to know, the food that you're eating or the milk that you're consuming, or say, if you know where it was captured from or where it was cultivated from, when it was cultivated, who packaged it, and then who processed it and then delivered it to your door, would you be happy knowing it or no?
Yeah, sir, very sure.
Right. For example, today's generation, you guys all order from Zomato and Swiggy, right? We all do that. This guy says that this guy has reached that destination. He will pick up the food. He's sanitized. His temperature is this much. He's now picked up the order. He's reaching to you. GPS thing has made the entire thing visible.
Yeah, just like we got in Amazon, Myntra, and all
Yes.
those
So,
websites. Yeah.
Yes. So the same thing is about traceability in the entire food chain from the farm, even before that, right? I mean, if it can certify that this guy has grown it organically, I mean, he has not put fertilizers and there are no MRLs and other stuff in the food. I think that is a wonderful thing for all of us to have.
That's very wonderful, sir. We got to know that we are eating the organic food or not, or we are eating something which was cultivated using pesticides or hydroponics, aquaponics. Everything we can know, and that's very, very interesting to know.
Yes.
Yeah, sir. Sir, with this, we are done with the questions, and I'm very thankful to you. You have satisfied all the queries of the participants and mine too. And it was indeed a very, very wonderful sessions. I enjoyed a lot, and I hope that all the participants have enjoyed it a lot. And thank you so much, sir, for joining. And we hope to see you again in some sessions online or offline. Whatever can be possible. So thank you, sir. Thank you for being there.
Thank you, Mani. Thanks a lot.
Yeah, sir. So in the end, I want to thank all the participants for your valuable time and patient listening. This training is being organized by the Partnership of Just Agriculture and Agro-Environmental Education and Farmers Welfare Society, Punjab, with NAHEP, MPUT Udaipur, Vidhan Chandra Krishi Vishwavidyalaya, West Bengal, and Utkarsh PDKV. We are also grateful to all our co-organizers and knowledge partners. And now I would like to thank and congratulate Dr. DPS Badwal, Organizing Director of this training program, Mr. Mohit Bhardwaj, Course Director of this training program, members of the organizing committee, all the speakers and attendees of this session. So thank you all for joining and have a great evening.